Effects of force. Force produces effects on shape, motion, direction, and speed. For example, if you take a balloon filled with air and press it, it changes its shape. You can see in the picture here, a metal rod bends on being given a few hammer blows. From this we can understand that force can change the shape of an object. A force can make a body move and can stop a moving body. You all have seen football match and a cricket ball match. For example, when we kick a football, it moves, but when we catch it, it stops its motion. Force can have effect on the direction. A hockey player strikes the running ball to change its direction. From this, we can understand that a force can change the direction of a moving body. Force can also change the speed of a moving body. For example, when you are pedaling a bicycle, if someone pushes you from behind or pulls you back, speed of the cycle changes. Have you ever noticed it? Now let us define a force again. Force is a push or pull which can make a moving body stop a moving body, change the direction of a moving body, and change the speed of a moving body. Let us do this activity on the effects of a net force. Choose a heavy object like a table that you can move only by pushing hard. Try to push it. Observe the changes. Now ask your friend to push in the same direction along with you. Observe the changes. Surely the table will move. We observe that it is easier to push the table when you take the help of your friend. The force applied by your friend added to the force exerted by you results in both forces being applied on the table in the same direction. The total forces applied by both of you makes it easier to move the table. Finally, now you ask your friend to push the table from the opposite direction to you. Observe the direction in which it moves. What is the final observation? We observe that the net force on an object is zero if the two forces acting on it in opposite direction are equal. That means your force and your friend's force are equal, then the net force of an object will be zero. It will get cancelled. Finally, we learned that all forces have both magnitude and direction. While adding forces, the direction of the forces has to be taken into account. When forces acting on a body along a straight line and they are in the same direction, the net force is taken as the sum of the two forces. The sign convention must be used to add forces. The force F1 directed towards the right could be taken as positive, and the force F2 acting towards left could be taken as negative. Finally, we conclude that if the two forces act in the opposite direction on an object, the net force acting on it is the difference between the two forces. Here, if F1, if your friend's force is greater than your force F2, then the net force is given by F1 minus of F2. You know why it is like that? Because your friend's force F1 was greater than your force. So the answer will be a subtraction of the two forces. The objects at rest moves in the direction of the net force acting on it.